Actually, it should be here only. I should discuss it, but all the things indicating here will be big headache. So I just kept it here. The moment you release, so in what direction this wedge will move? Another block is telling find the range of values of m. So definitely this should move up. So then O will make it to move up. So I'll start with this one. So here the moment I release, what are the forces acting? Mg sine theta. Normal reaction N1, then N1. Mg cos theta. This N1's component of this normal reaction, what it does, it will exert force on the wedge in this way. Oh. So because of this, the wedge will move in this way towards right. Sir, you can ask primary question. Sir, here also block is there. It will also exert a force. What's wrong here? This also will come into picture. No? N2. Then because of N2 sine theta, because of N2 sine theta, the wedge will also move towards left. But what is the primary condition given for us? This smaller block should rise up. So for that, the net force on the wedge should be towards right. But are you sure? Look at the wedge. One more troublesome. Wedge is having any mass? Light material. Okay, now this is massless. So what should be the N1? N1 should be equal to N2. No doubt. Okay, later part, this is going to help us a lot. So here N1 sine theta minus N2 sine theta equals 0. Why it is 0? Because now mass is 0, but it can have acceleration. So therefore, rather than writing it, I'll end up some mass of the wedge and A naught. As wedge is massless, so you have very good problem. It is wedge is massless means m naught 0, but acceleration will be non-zero. This is a very primary important condition. A body which is massless, can it have acceleration? That's what the example is, what I'm wanted to bring here. Are you noticing this? This part is something very important for us conceptually. What do you think? Okay, light body should not accelerate. Light body also will accelerate. Let's get into the next part. So we'll write all the possible equations. So pseudo force will act here. Ma naught. Then other forces that are acting are mg cos theta. What makes the small block to slide up? Ma naught cos theta should be greater than mg sin theta. Find the range of that vector. So we'll take the minimum at least. So ma naught cos theta equal to mg sin theta. So a naught equal to g tan theta. This should be the acceleration of wedge. And for what is further, n2 is equal to n2 minus mg cos theta minus ma naught sin theta equals 0. Solving this, a naught is what? G tan theta. Solving this, I think you know all these are some very standard things. Instead of doing all this, you could have written directly a naught and n2. Okay, fine. After this, let's look at the let's look at the wedges. Anyway, we have concluded already n1 sin theta, n2 sin theta, but still the value, find the ranges of values of m in terms of m and theta. Small m should come in terms of capital M and d. Any equation can we bring? I think I to just give some time for students to think. Okay, I'm asking you to look at this block. Okay, look at here. As the wedge is sliding, what is the motion of the block? It will move somewhere in a plane like this. But with respect to wedge, how it will move? Along the incline. So is there any relative acceleration between the block and the wedge perpendicular to incline? The answer is no. So there is no, what we can write? There is no relative motion between the block M and wedge along perpendicular to incline. So therefore, so what we can write based on this I'm going to write N1 minus M1G cos theta minus M1 A0 sin theta. This you should know how to justify it. Is it N1 minus M1A not sin theta or plus M1A not sin theta? I think there is actually, this will be wrong. If I write it in this way, it will be correct. Now, sir, from where you have brought this equation? I think this is the main important part of this problem. Pseudo force, I applied a pseudo force. Nothing is there. That pseudo force, let me. So MA naught N1 sin theta should be equal to M1G cos theta. Why it is like it? Because there is no relative motion between the block M and the wedge along perpendicular incline. So I got now the value of N1. So what is N1 equal to? M1G cos theta minus M1A naught sin theta. This is equation 3. I think okay, we are at better place. There's a constraint, wedge constraint is what? I have brought it. So solve 1, 2, 3. You get the required answer. And N1 equal to N2. We will write it. I think complete problem is there. N1 sin theta minus N2 sin theta equals 0. Therefore, N1 equal to N2. This is the equation 1. We will change it. It will be 3 and call this is equation 4. So solving 1, 2, 3, 4, we'll get the required answer. So what should be the mass of the block? Should be equal to small m. What is this small m? It is a small m. This small m, this mass of the M2 should be less than or equal to m1 cos theta, cos 2 theta. Solve it, you'll get this answer. How do we get? Solving 1, 2, 3, 4. So I think the green color, what I highlighted is something very conceptual, which will help us a lot. The green color one. This is something very fundamental. That in theoretical somewhere is there. So that's why I just took one example itself so that you can see that. I'll move to the. Okay, we'll discuss. There's one more.